On this episode of Full Tilt Nerdity, Microcontrollers. I'm John Latshaw, and welcome to Full Tilt Nerdity. In this episode, we're going to take a look at microcontrollers, what they are and what they can do, and why they're nerdy. First off, what is a microcontroller? Well, a microcontroller is a special kind of computer. Don't go away. Just stay with me. This is going to be interesting, I promise. Look, microcontrollers are all over. They're everywhere. They're in everything. They're in your televisions. They're in your microwaves. They're in your car. Everything nowadays is run by microcontrollers. Now, what is a microcontroller? Well, a microcontroller is basically a special purpose computer. It's designed and programmed to perform a specific task as opposed to a general purpose computer like this laptop, which can do all kinds of things like word processing and database and serve up web pages and browse web pages and play games and edit video and all of that sort of stuff. A microcontroller has a much more specific function. Let me show you. This is a microcomputer. This is a microcontroller. Yeah, I know, they look very similar, but stay with me here. One of the things that has exploded over the last several years in the maker community is the availability of small, powerful microcontrollers. This is an Arduino. It's designed by an organization in Italy and is available as an open source design, which means anybody can manufacture these. In fact, this is not even an actual Arduino. This is an Arduino clone that I bought for $5. It has a microprocessor, it has memory, it has input and output functions, it has a lot of the things that you would expect on a computer. But it's not a computer, it's a microcontroller. We'll get back to that in a second. This is a computer. This is a Raspberry Pi. It's also designed by an organization in Europe, in this case in the United Kingdom. It has a very powerful microprocessor, it has memory, graphics, and it has a lot of the things that you would expect on computers like USB and Ethernet and Wi-Fi and video. This is a computer. This is a microcontroller. The difference between the two, while they physically look similar, they're not. The Raspberry Pi is a full computer. It can do all of the things that this laptop can do. It can do word processing, it can browse the internet, it can serve internet pages, you can edit video, you can play games on it, you can stream or serve up video. All of the things that this laptop is capable of doing, this can do. It runs a full version of Linux and it has a full file system on it. The microcontroller doesn't have all those functions. It has a very rudimentary file system, if one at all. It has very little in way of an operating system, actually more of a bootloader. And it doesn't have all of the I/O that the Raspberry Pi has. It doesn't have video, it doesn't have Wi-Fi. It does have a USB port, but that's really acting only as a serial port to connect it to the development system. What it does have is it has a ton of I/O, pins that the processor can read directly and act upon. And this is important for a microcontroller because on a microcomputer, those pins are actually being reserved for things like the USB and the Wi-Fi and other outputs instead of being broken out as pins directly to the microprocessor. Those have to be run by drivers, by software that converts the raw commands of the microprocessor or the raw data coming in from the outside world into something that USB or Ethernet can understand and then convert it back. That introduces overhead or latency that when you're controlling something in real time, you really can't afford. Microcontrollers allow you to read that raw data and act upon it immediately. So that's why these are used for things like controlling robots, controlling the environmental control system on your automobile, running your microwave oven, or running your TV set. Now, the Arduino takes that power that which had only been available in things like assembly language programming and very complex development cycles, and made it available to the maker. And with the Arduino design being open source, anybody can manufacture these. In fact, it's very simple to take, once you've developed something for the Arduino, to actually basically break it down and build your own Arduino into your design. So we're going to look at Arduino. And Arduino has an open source design. There are many variants of it out there. And it also has an open source development environment that's available for Windows, Linux, and Mac OS. And what we're going to do is we're just going to play around a little bit with it. This is going to be very simple. I'm not going to build anything complex because honestly, I don't know how. I'm learning, and you're going to learn along with me, I hope. Assuming that I learn, right? Right. Okay, so first thing we need an Arduino, which we have here. Another thing we're going to need is a bucket of electronics. And what I have here is I have a kit that I bought, and it has some LEDs. It has a USB cable. This is for connecting the Arduino to the laptop so that it can communicate and get the software down once it's been created. And a variety of components. Here's a 10 kilo ohm potentiometer. Here's some resistors. Here's a single RGB LED. Here's some amber LEDs, blue, red. Here's some capacitors. Here's some tack switches. And a breadboard, and lots of hookup wire, which we will be needing. Now, the breadboard is going to allow us to plug in components directly into this so we can prototype a circuit and then connect it to the Arduino and get it, hopefully, to do something. So now we build. Okay, as you can see, we have this working. The Arduino is controlling this LED using this pin and this code that is running right now. It's a very simple circuit. Power is coming off of the Arduino, provided right here on these pins, and is going to the power bus, power rails here on the breadboard. Now, the power, or the digital switch, number 13, is being connected here. It comes over to this resistor, comes through here, goes to the LED, and then it goes back to ground through the rail, back over here to the Arduino, to the ground. Now, what's making this work is the code. Arduino code has two parts. The first part is the setup. And the setup basically is executed once when the Arduino is powered up. Here, it sets up a pin and allocates it as being the built-in LED pin. And it says this is going to be an output. Then we go into the loop function, and this is executed over and over and over again until the Arduino is powered off. It starts out by writing a value, high, with a 1 or a 0, high in this case. It is delayed by 1,000 milliseconds, or 1 second. Then it's pulled low, or a 0 is written to it. And then the delay again for 1 second. So it'll go on for a second, off for a second, on for a second, off for a second. Now, if we went in and changed the code to, let's say, 500 and 500, then we compile the code. Now we upload it to the Arduino and then hit the reset button on the Arduino, now you can see it's blinking twice as fast. Okay, now I've moved the pin from the digital pin over to this analog pin, and we're going to do something a little more complex. Well, it's not that much more complex, but follow me here. We have a new sketch. Before the setup, it sets up several variables. First off, it sets up a variable for the pin number, a variable for brightness, and then a variable for the amount, how far it's going to change the value of the brightness of this LED based on each iteration of the loop. Then we go into the setup and we declare pin 9, which we have up here in the LED, to be our output. Then we go into the loop. First, we write out to pin 9 the current level brightness, which in this case will be 0. This pin is an analog pin. As you can see, it's a little bit different command from the last time. This allows you to write a value other than 1 or 0. It allows you to write a 0 to 255. Then we're going to increment the brightness, either up or down, and then we wait 30 milliseconds to loop through it again. And now we see the LED fading in, fading out. So what is this good for? Well, obviously we can make a light blink. It's very basic, I understand, but you know, it's a starting point. I mean, granted, you're not going to make much of a product, you know, for something that just makes a light come on and go off. Unless, you know. But that's basically what's going on in here. There's a microcontroller in there that plays the sound effect and makes that light go on and off when the switch is activated. That's basically what this is. And see, it's not that complex. So there you go. That's our introductory look at Arduino. It's nerdy and it's cool at the same time, and it's very versatile. There's a lot you can do. To say we've scratched the surface doesn't even begin to cover it. We haven't even come close to scratching the surface. There's so much that can be done with Arduino and electronics. Our world is built on these sorts of things, and this opens that up to the individual maker. I hope that you'll stick around with me as I learn this. Please, please subscribe. I need subscribers at this point because, well, I need subscribers in order to get a full channel name instead of a cryptic bunch of numbers and letters for the channel name. So please subscribe, tell your friends, and leave your comments in the comments below. I really welcome them and look forward to the feedback. So until next time, stay nerdy.